Mass timber is a great material, but it's not the only material out there, and we certainly utilize different materials together to create good engineering, especially as a student, and be open-minded to what else is out there. Certainly, when I graduated from university, I thought, "Oh, I'm gonna be mass timber only." But I certainly took a journey to get here. I did a lot of steel design and I did a lot of concrete design. And that all leads to understanding engineering principles and fundamentals, right? Because at the end of the day, that's what matters.
This is the Mass Timber Group Show. I'm Brady, and today I caught up with Jamie Pobre Sullivan with Fast Epp, the structural engineering firm for the British Columbia Institute of Technology's new hybrid mass timber student housing building. Jamie gives us a deep dive into the structural systems and construction process, including the use of Western Hemlock CLT in a point-supported structure with steel hollow structural section columns. We unpack the lateral systems, cores, facade, and how they all impacted the construction schedule together. But before we get into the podcast, if you want to see in-depth coverage of other mass timber projects like this, check out the link in the description below. We just started doing original coverage on mass timber buildings in North America in written articles and in other podcasts. You can see them on our website and even request coverage for one of your own projects. If you like these podcasts, subscribing to the channel is the biggest compliment you can give us. You hear it every time you listen to any podcast, but it really does help the show grow and reach more people with the mass timber information like this. So if you're not already, please hit that subscribe button. So with that, let's get into it.
I'm Jamie Pobre Sullivan. I'm an associate here at Fast Epp, and today we're going to talk about the BCIT Tall Timber Student Housing Project located in Burnaby in British Columbia, so a suburb of Vancouver.
What about this well, first let's get into what kind of structure it is, the size,
Sure.
scope, and all that. What does this project look like?
Yes. So it's a 12-story student housing tower. It's got 11 stories plus a roof, CLT point supported mass timber floors supported on a concrete podium. It's got one level of basement below grade that is just used for storage and mechanical units. And then the ground level is simply amenity space, office space, laundry, utility, more utility. And then the 11 stories above are all single occupancy, single suite rooms for students.
So you said it's a CLT point supported structure. What went into the decision-making process to use that type of system?
This project truly was a Brock Commons 2.0. If you don't know what Brock Commons is, that's at the University of British Columbia here, that Fast Epp designed and completed between 2015 and 2017. That building was 18 stories of CLT point supported, very similar system, half the size though in floor plate. And that project basically rewrote the code in terms of what was possible for tall timber. So people now still talk about it. And I think the client, BCIT, really wanted something similar and wanted to benefit from the advantages that they saw out of that project. So it was cost competitive to the very typical concrete tower here, but it had better biophilic properties, right? We're getting rid of the highest volume of concrete, which is very carbon dense in the building, and replacing it with something that is very sustainable. Brock Commons also went up very quickly. I think it was something like 1 week per floor, very similarly. And they wanted to achieve the same sort of speed for their project here. So that was a large impetus as to why we went with that system. They saw the benefits of that project, and that is also a student housing project, and they wanted to apply it to their building.
Just got done talking about the system there. Can you tell me why you went with the steel hollow structural section columns?
Coming out from Brock Commons, that system certainly used a very typical concrete core system. And we certainly see a lot of that here in Vancouver. But we wanted to find another way to prefab the structure. There were a few proprietary things out there, like the Ready Core system that was a concrete system, but they just were not tuned to the high seismicity that we have here in Vancouver. So we thought, let's do steel, because with knowing that we could go with something that was very shop installed prefab and then lift it into place. That took some work. We started off with single blade walls, like for brace frames, and then we slowly tuned it so that we could take advantage of the egress cores around the building in such a way that made them not just prefab, but self-stabilizing, meaning that we could limit how much temporary shoring, right, that we needed in construction.
Were you able to hide those inside of the wall so it didn't interrupt the flow, or do you still how did that work?
Yeah. So what we did was we recognized that so the tower is L-shaped, and so by code and by architecture, they needed stair cores at each end, or what we call the bookends. They needed a middle stair core in order to break up the longer bar on the south side, and then they needed a central elevator core. So we quickly recognized these zones, if you will, and said, let's just use that. And so not only did we use those in like C and box shape forms in order to make the self-stabilizing, it gave us enough redundancy using 4 cores instead of 2, let's say, that we could minimize the sections of the frame to hide them within walls. We still have to work around like big columns, but for the most part, the braces were not an issue. We were able to hide those within the walls, and these are all big fire-rated walls for the stair. So yes, we were able to fit that in and we weren't necessarily going in between suites with our lateral system. We were going in between like big sort of demising walls for big egress cores instead. So once we shifted our mind into that, it became like less hard to hide that structure, if you will. And in fact, they are exposed in some areas, the braces, that is, for effect. And because in the end, the architect and the client didn't really see the need to hide them. So there's like one stair core where one bay is exposed up the building.
Yeah.
Which we like.
Combining that system with the CLT, and you guys actually used hem-fir CLT for this, and you guys had to take it through some extra testing to use it in this application. Can you tell me about that?
Yeah. So the original design was actually spruce pine fir, which is very typical, right? It's what we see. It's because it's moderately affordable in comparison to Doug fir, which is like the premium. But hem-fir is not commonly used. One, because hemlock is maybe not readily available in some areas of North America, but here in BC, there are huge hemlock forests. And hemlock has some funny properties about it that make it really hard to dry. But if you understand how to dry hemlock properly, a lot of those issues kind of go away, like warping issues. So we only went to hemlock in order so that we could deal with some on-site delays that we were seeing. And by diversifying their fiber basket, if you will, Kolesnikov was able to, and that's the supplier, Kolesnikov Mass Timber, they were able to essentially treat this on-site delay as if nothing happened. We said, okay, well, we can use this like a wider fiber basket. We just move you in the queue and away we go. They were specifically tuned to using hemlock because they're their own sawmill. They have a lower risk, because they're not buying off the market. They understand hemlock as a material, how to dry it as just a regular, like it's part of their lumber basket. And so we felt comfortable in that realm. They understood how to dry it. Then on top of that, we were already doing a lot of point-supported CLT testing in conjunction with University of Northern British Columbia to better understand some of the rolling shear properties of CLT. Because the code has very conservatively assumed some lower values for shear. We had done our own sort of desktop studies looking at what Europe is doing and trying to truly understand the complexities around rolling shear. And that's what helped us to design the building back in 2021, 2022. But then in 2023, we were already doing all this testing. Hem-fir was part of that testing. And what we saw as a global trend in all of the 190 panels that we tested was that in general, rolling shear values were higher than the standards were giving us. Um, and because we had hem-fir from various manufacturers in that batch, we were then also able to confidently be comfortable switching from SPF to hem-fir.
Do you think that process that you just outlined is going to open up more applications for hem-fir in BC?
Absolutely. So this is the largest sort of commercial use of hem-fir as a CLT material, and it will definitely open it up. In this process, also, I think the supplier made it ready to be certified as well. So as you will, like off the shelf. And so all of that desktop study and actual physical testing that we did, I think does open the door for this to continue to be used, as long as you get a supplier who really understands how to dry out that hemlock material.
It's not, I'm 99% sure it's not hem-fir, but Klesnikov just supplied a building that's a couple blocks over from me.
Oh yeah.
So I've been talking to all the people about working with those guys, and I've heard nothing but good things. So
yeah.
So we've talked about like the testing and the data behind what you guys put together, but can you tell me about like the realities of the construction schedule? How fast did it go up? What did you guys see there? Because I know it's a big talking point around mass timber.
Yeah, we honestly talked about construction schedule almost to death during design. We had an early design assist partners. So our now general contractor, Ledcor, was our construction manager starting in develop design phase. They brought on the key trades. So that was steel, that was mass timber, and then that was facade. So the prefab facade. They came on early to really guide the consultant design group just in the right direction. And design assist is a form that we see more and more when the client is especially concerned or mindful of things going well in construction. And in this case, it really paid off. We asked a lot of questions at the beginning on how to not just speed up construction, but simplify detailing such that fabrication was almost as much as possible prefab. And therefore, everything could show up on site and come together as a kit of parts in its true form.
Did Kolesnikov do that?
Kolesnikov was part of that design assist, yes. But I would say that in some ways, the bigger conversations were around the prefab curtain wall and how we were going to detail each steel connection so that things could go seamlessly on site. So when it came to it, it was planned this way and pretty much went this way, is each core was going to take 8 days to erect. The central elevator core took 13 just because it's bigger and more complicated. And that's essentially what happened. I think we took a little longer to finish out some of the on-site detailing, but as much as possible, a lot of the critical details were done in the shop. We planned for the CLT to go down and be installed. I think it was 1 floor per week. And just to keep something in mind, our building plan area is twice as large as Rock Commons, which is the big brother we were looking up to the entire time. So we were twice as fast.
How many square meters or square foot was each floor?
Each floor. I'm not sure. I think it's on the order. The whole building is 250,000 square feet. So it's about 20,000 square feet.
Wow. So you did about 20,000 square feet a day laying those panels.
Yes. Now, a big consideration not only was speed, but also how fast can we close in the building. So a large part of the discussion was around moisture management, moisture mitigation and management. Our general contractor, Lightcore, was a huge player in this and consulted not just us as experienced players, but Lesnikov as a supplier, and RDH, which is our on-board consultant. And they came up with a full comprehensive plan on how they would actively manage the moisture. Now, we're in British Columbia. You cannot avoid moisture. It's going to rain. Like whether it's summer or winter, it's going to rain. And so it was not a matter of preventing moisture. It was just, how are you going to dry out the panels?
Yeah.
And so not only were they actively, like just literally pushing water off of the panels, everything down to what sort of membrane we were going to shop install on the panels. to even like how quickly are we getting the facade up around these panels. So by the time we hit the second floor, the third floor of CLT, there was always one floor being enclosed 2 levels down. So that's, and visually when eventually we get the time lapse together, it will look like this building is being constructed even faster than your average because of this like sequence that we followed throughout until we topped out. So by level, I think 2, 3, 4, by level 4, they were laying down CLT in a week and then taking another week to then erect all the columns for the next floor. So prep for the next floor. And then meanwhile, in that week, 2 floors down, 1 floor was being totally enclosed with the Flynn speed wall system, which was our facade. So that continued, and that meant that that floor being enclosed could slowly dry out, right?
Yeah.
So by the time we hit the roof, that first floor, which we started in mid-February, had, about 3-4 months to just dry out completely. And a little less time because actually then once we hit 4 floors, 4 floors down was being encapsulated with the gypsum.
Okay. So you guys are kind of like running up the building with different partners, like as you go. So you don't have to wait for everything to get topped out before you start from the bottom on the facade and go back up.
Exactly.
What did you guys do any comparisons on like, hey, if we did cast in place concrete on this, et cetera, like what the schedule differences were?
Yeah, there was a bit of that. I think in the end, we found that we could be just faster than cast in place concrete for cores with the CLT. I think that the differences are that it's just more labor intensive on site.
Right.
So you can get that labor to speed up when you're doing cast in place concrete cores. And we certainly see it here. They use jump forms. This town is very good at cast in place concrete cores. But this was just, another way to do something. And it was just a tad faster. And what we really enjoyed as a structural engineer was that so much of the construction could be done in the safety of a shop.
Yeah.
Right. So we get better quality. We have fewer site reviews for it. We do everything in shop drawing review. It's third party inspected because of all the welding that's done. To us, it assured a bit more quality for sure.
Completely, I understand that. So during this whole process from planning to execution, were there any misconceptions or knowledge gaps that you kind of encountered through your AEC partners that got addressed, or that you noticed was like, hey, here's something the industry could do a little bit better at informing different trade partners?
I think I saw the biggest leap in development with our steel trade, I would say. This is a pretty tall building to be doing concentrically braced frames. And, we saw them go from asking a lot of the more basic questions of, oh, can we bolt this connection instead of weld it, to asking us right before construction, like, hey, how about we just simplify this? Instead of you having to have splices every 2 floors for the cores, you just do 1 splice, which as a structural engineer, we also like because we don't have to design these various splices. We'll just get the biggest mobile crane to go along with our tower crane, and we'll just lift up a 5-story piece that we've shop welded.
Yeah.
And it was like, yeah, sure.
Of course.
Yeah. And I think once they understood the assignment, that they had to have tight tolerances to marry with the mass timber, that they needed quality and had to play with the construction schedule just as much with simplicity. They started to ask some really good questions and started to be proactive about it. The 5 and 6 story lifts was one of the biggest ones, and certainly they were being pushed by the general contractor. To think about schedule. But in the end, that was the reason why we saw a core go up in 8 days.
Yeah.
In big 5-story and 6-story lifts.
Yeah.
So each core is about, in the end, just 8 pieces. So piece per day.
So there's a lot of
Pretty cool.
back and forth collaboration. I won't call it problem solving, but maybe solution finding, right? Like, hey, how can we make this
Yeah.
simpler, better, faster? And it sounds like everything came together. Did the schedule complete on the timeline that you guys originally thought?
On the grand scheme of things, yes. There was an on-site issue with groundworks that slowed us down at the very beginning. But in general, once we got through that, the building did go up pretty seamlessly.
Yeah, I love to hear that. This was kind of like a showcase mass timber piece in BC. So, from your perspective, what were kind of the most significant ways that this project advanced the use and understanding of mass timber in your specific region?
I think, yeah, it is a showcase. Unfortunately, none of the CLT is going to be exposed. But what it does do is it follows to the letter of the code. The code. um, it is max 12 stories, which at the time was the maximum that you could go. It's what we consider partially encapsulated, meaning that it relies only partially on gypsum board layers for for fire resistance rating, and then we've designed the CLT to char for the remaining amount of that fire resistance rating, again per the code, and so I think it really showcases that you can do this, and with the construction scheduling that we hit and the success of that, I think it also just showed, like, yes, you don't always have to go with a concrete tower to be successful. You can do mass timber, and you can do it hybrid. You don't have to be tried and true, mass timber all the way.
Yeah.
And you can make it successful with different materials.
Yeah,
I
I
think
like.
that's really what it underlines.
Yeah, I'm hearing more and more conversations around, hybrid is the future. Like we're doing hybrid different. We're using different materials, integrating different materials. It doesn't all have to be, strictly mass timber or steel or concrete, et cetera. It's like, how do we blend these to get the best of both? And I think that
Yes,
this is what
yes,
this project demonstrates that. Yeah.
yeah, and the Fast Epp too. We're known for our mass timber and our detailing and our crazy mass timber designs, but always we think about, where does it make sense? Does it make sense?
Yeah.
It doesn't. If we're just pushing mass timber for the sake of just mass timber, it doesn't feel right.
Yeah.
We push it so that it's either being showcased in a way that we appreciate, or in a way that makes the most sense for the client and for the project itself.
Yeah. Totally agree there. So, looking beyond the BCIT project, what are some of the more interesting or things that excite you that you see on the horizon in mass timber design and construction?
So we're seeing it pop up more in social housing, which I think is important, right? Especially with that like construction schedule in mind, with the biophilic property, the sustainability card in mind, that yes, we want to be building more housing to address this housing crisis, but we want to do it in intentional ways, in ways that serve the public, in ways that serve our future. So that's a big story with mass timber. I think though the area that what I'm excited about is in the like hotel and hospitality.
Mm-hmm.
We see I think even more adjacent to student housing is hospitality.
Totally.
You get very repeatable suites. They're single occupancy oftentimes. They really just want to be there for someone who lives there for short term or stays there short term and is out.
Yep.
And that's kind of what student housing is. The challenge with multi-residential construction is that you get like 6 different layouts, and they want to be 4 bedrooms is a dream, and then they want balconies, and then and those all add complexity to, especially to a point supported mass timber system. And so there are ways of working around that. We certainly have, but with a hotel, it seems like they want to go up quick, they want to be simple, they want to be pretty straightforward. And
Yep.
I just see that as, well, why not use the BCIT student housing project as a model for that?
Totally. And I talked to a lot of developers in the Colorado area leading up to our conference this year. And the folks that showed the most interest and the most openness to learning about mass timber were hospitality developers. So I think you're on the right track there for sure, because
Yeah.
like you said, it's, it outside of students versus tourists, let's say, like, it's all the
Yeah.
same layouts, it's all the same form and function. And I think what's unique about mass timber in hospitality is it's different, it's unique, it provides a different vibe other than like your standard hotel, you know, wallpaper, carpet, etc. Like
Yeah.
even if you're not exposing it everywhere in the rooms, like you can expose some part of the structure and it just adds a unique element that differentiates the product. And I always hear, one, it's got a pencil, right? Two, it's got to be quick. And then three, it's got to differentiate your product in that space. And so
Okay.
I would love to see more mass timber hybrid hotels come out in the future.
For sure. And if we look at like the Las Vegas market, for example, where it's all hotels, they blow up those hotels
Yeah, they do.
every couple decades. And not that I want to see a mass timber building blow up. That it's not what I'm getting at. What I'm getting at is that there is a question that often gets asked is like, should we take apart this building in the future if we had to? And I think that becomes easier with some of these mass timber hybrid buildings, especially BCIT. I think I can see a world where that building can be disassembled with a lot of care and a lot of work, but more so than a concrete tower.
Yeah.
That just gets demolished, right?
And that's looking at like the total life cycle cost, right? And so like you're talking about the grave end of that, right? So there's costs associated with that, whether it's financial or carbon or what have you. And, especially when you're talking 40, 50, 75, 100 years in the future, like, do you think that municipalities and government agencies are going to be more lenient about blowing things up and throwing them away, or more strict about reusing and recycling?
I hope they're more, I hope they're more strict. That's for sure.
And especially as like somebody that's looking at that asset, later down the line, I think that's definitely part of the conversation that'll come in is like, hey, can you disassemble this? Can you recycle it? Can you deconstruct it? Or even if it, heaven forbid, it all goes to the landfill, at least it's wood, right? So concrete. So no, I like where that's going. I hope to see more of it in the future. Couple quick questions for you before we hop off. I always like to ask everybody where they're going to learn about mass timber, how they're advancing their individual trade and practice. So where does Jamie go to learn?
Honestly, I came here Fast Epp. There are so many like senior experts here in Paul Fast, and even in what he and Jerry Epp did and why they did it. That has been my biggest education, is working with Paul and with the other senior engineers. Ian Boyle here was the EOR for this project, and I learned a ton just working under him. So honestly, it's been my peers that I've worked, that I've learned the most about mass timber, and Fast Epp in general. I know it sounds very loyalist, but
no, not at all.
It's truly why I ended up here.
Well, I'm going to ask you a follow-up question to that. So you just demonstrated that you learned so much from your peers, and then especially in the mass timber realm. What are you going to do to help other engineers learn about mass timber moving forward?
Stuff like this.
Yeah.
Just getting the word out, presenting, showing up and being very present. Honestly, a bit through mentorship as well at the local universities and amongst local high schools even. And just speaking more about what it is that we do and that I do, how I'm a part of it. Because I'm always very happy to talk about, to myth bust and to talk about what works and what doesn't and why and how we can change that.
Yeah. Yeah. I love that answer. So before I ask my last question, where can people connect with you and the company?
Yes. So they can visit our website, fastepp.com. You can Google Fast Epp as well. We're here in beautiful British Columbia in Vancouver. We do have a concept lab, which is a full laboratory. So really, if you are in town and interested, you should come by. It's not totally an open door. You have to let us know that you're coming. But I think it's great because, and I mentioned concept lab because it is literally a physical space to see some of the things that we do without having to be necessarily in those buildings. Our building is also like our own sort of like living lab, if you will. We built ourselves a mass timber hybrid building. so we can see all the connections, and we can see our own lateral system, and we certainly push the envelope there as well. And you could find us on LinkedIn and all the socials and so on.
All right. Well, I'll be sure to link all those down there in the show notes below for people that want to get in contact with you. So you kind of teed up my last question with your answer. So hypothetically, let's say that you're in an elevator for 60 seconds and an engineering student is standing next to you and they ask you about what you do and mass timber. What would you tell them?
I would say, yes, I'm a structural engineer. I work at Fast Epp, and mass timber is a great material, but it's not the only material out there. And we certainly utilize different materials together to create good engineering, good projects and building projects, and that they should explore, I think, especially as a student, and be open-minded to what else is out there. Certainly when I graduated from university, I thought, oh, I'm going to be mass timber only. But I certainly took a journey to get here. I did a lot of steel design, and I did a lot of concrete design. I did a lot of design, like even just non-structural anchorage within hospitals. And that all leads to understanding engineering principles and fundamentals, right? Because at the end of the day, that's what matters over just materiality, is really understanding how something works and why it works and why it might not make sense for the application that we're looking at. And so being open-minded really about any and all materials and why we would use them is maybe what I would tell this young
that's
student.
A fantastic answer. I love hearing hey, mass timber is great, but you have to know more than just mass timber. You got to explore a little bit more.
There's more to it.
We touched on it. Like, it integrates with all these other different materials. Like, you can't be a master in a sole solitary material or subject because they all cross collaborate and integrate. So that's a great answer. That's all I had for today. I wanted to thank you for jumping on, telling me about the BCIT project, Fast Epp's involvement, talking about some structural engineer topics on here. So thank you for hopping on. And I'm excited to watch the project come to completion next spring. And I'm sure we'll have a time to unpack the finished project later.
Thank you.
Yeah.